Hello and welcome to Mr. Barton's autograph video number 35. Now once again this week we are going to be doing some work with our lovely 2x2x2 cube, and the work we're going to be doing is about planes of symmetry. Now if you missed how to construct this lovely cube, then you might want to look back a couple of videos ago and that'll talk you through how to construct it. Okay, so before we start, a little bit of a backstory. I was teaching my lovely Year 9 class who are very bright about a month or so ago, and I was teaching them about transformations, and I noticed on the new GCSE specification there was a thing about planes of symmetry, so I thought we best cover that. So I just chucked into the mix a little question. I drew a cube on the board and I said, how many planes of symmetry does this cube have? So how many ways can I slice this cube so that when I make the slice the two parts are identical, perfect reflections of each other? And I thought this would be something that we'd chat about for a few seconds and then move on. However, as I went round the class, there was about 7 or 8 different answers offered up. And indeed, as I went round the maths department, there was about 7 or 8 different answers offered up. And indeed, when I asked myself the question, I got it completely wrong. So, my question for you is this. Firstly, how many planes of symmetry does this lovely cube have? And for a bonus point, what are the equations of those planes of symmetry? And maybe you might want to pause this video and then resume it and we'll have a little talk about it. Okay? Right, welcome back. So, planes of symmetry of this cube. Now, I couldn't believe the answer when I heard it, and just to put you out your misery and pat yourself on the back if you got this right, the answer is indeed 9. There are 9 distinct planes of symmetry. And I thought to myself, nah, that's got to be a load of rubbish, because it's an odd number, and everything about a cube is even. I mean, it's built up of squares, which are all to do with 4s, it's got 6 faces, it's got 8 vertices, it's got 12 edges, so where on earth does the 9 come from? Well, it's only when you start thinking about the equations of those planes of symmetry that the 9 pops out. And I know planes of symmetry aren't covered until A-level, and in some equations of planes aren't covered till A-level, and even further maths sometimes, but I don't think that's any reason not to talk about them with younger students. Because if you ask a student what on earth does x equals 0 look like in 3D, it's not that hard a concept for them to get their head around, because if the only restriction is that x is equal to 0 and y can be whatever it likes and z can be whatever it likes, then it'll be no surprise what it actually looks like. So let's have a look at x equals 0. So I'm in standard mode, so I don't actually have an enter equation button here, but that's not a problem. Just hit enter and up comes the add equation. So x equals 0, let's have a look, and there is our first lovely equation, plane of symmetry. And if x equals 0 works, then there's no surprise that y equals 0 is also going to work, and there's that one there. And finally, the other one to complete that set is obviously z equals 0. Now, there's 3 already. And now what I really like about this is that the other ones, the other 6, follow a nice symmetrical pattern. So I'm just going to select each of these ones in turn and delete them. Because you can also ask your students what they reckon that the line y equals x would look like in 3D. And again, if the only restriction is that the y coordinate has to be equal to the x coordinate, then the students can kind of understand that if z can be whatever it likes, it's got to extend infinitely in that z axis, or in that z plane. So let's have a look at y equals x. So y equals x, and there it goes there, slicing down through the cube. Well, if it slices down that way works, I wonder what the equation will be slicing across that way. Well, again, it's beautiful symmetry this, because that's just y equals minus x. So there's your 2 kind of vertical diagonals there. And remember, we can always hit this button to return. So we're up to 5 already. And then the other 4, again, follow a nice pattern. If you've done y equals x and y equals minus x, you can now do y equals z. It's that little slice through there, and you can also do y equals minus z, which is that slice through there, and then your other 2 to complete the party, if I just delete those, are going to be your x equals z and your x equals minus z. So it follows a lovely pattern, and that's where your 9 planes of symmetry of your cube come from. More work on our lovely cube next week. Hope all's well with everybody. See you later. Bye bye.